Hi, my name is Nur Alia Maisara binti Muhammad Zaharin and my ID number is 2024426094.
My name is Siti Damia binti Zakri and my student ID number is 2024650656.
My name is Ania Safina binti Muhammad Rizal and my student ID is 2024642366.
My name is Nurul Izzah Farihah binti Firdaus. My student ID is 2024233264.
When we are given a long statement with more than 3 simple statements, building a big truth table can be complicated. To avoid this, we can use set of rules called the laws of logic to find logical equivalence easily. In this assignment, our group will apply these laws to simplify statements and understand how they work in practice. We would like to express our heartfelt gratitude to our respected lecturer, Madam Aisha, for giving us the valuable opportunity to carry out this project on the topic Law of Logic. Her continuous support, encouragement, and insightful guidance have been essential throughout the completion of this assignment. We are also truly thankful for her patience and willingness to guide us. Without her help and dedication, this project would not have been possible. A special thanks goes to our group members for their excellent teamwork, effort, and cooperation.
For the content, me and my friends will explain 13 types law of logic. First, identity law. P and true logical equivalence to P, or P or false logical equivalence to false, which means if a variable and T, which means true, logic will get variable, and if a variable or false, you will get the variable. Second, domination law. P or true logical equivalence to true, or P or false logical equivalence to false, which also means if a variable or true, you will get true, or if a variable or false, you will get false. Third, idempotent law. P or P, you will get P, which means logical equivalence P, or P or P logical equivalence to P, which means if it's the same variable, means either it's N or you will get the variable. Fourth, double negation law. Not bracket not P logical equivalence to P, which means if it's not mixed with not, the not will be disappear and you will only get the variable. The fifth one is commutative law. P or Q logical equivalence to Q or P, or P or Q logical equivalence to Q or P, which means it's both of it is a different variable, either it's N or you can exchange it like P or Q and you get Q or P, it's still the same.
Next, associative law. Associative law allows us to regroup proposition in a logically expression without changing the truth values. Here we have some example. P or open bracket Q or R close bracket is logically equivalent to open bracket P or Q close bracket or R. Same goes to P and open bracket Q and R close bracket is logically equivalent to open bracket P and Q close bracket and R. So for distributive law, P or open bracket Q and R close bracket is logically equivalent to open bracket P or Q close bracket and open bracket P or R close bracket. Next, De Morgan's law. Not open bracket P and Q open close bracket will be not P or not Q, while not open bracket P or Q close bracket will be not P and not Q. So for inverse law, P or not P is logically equivalent to T if P and not P is logically equivalent to F.
For contrapositive, P implies to Q is logical equivalence to negation Q implies to negation P. Then we have conditional identity, and for conditional identity, we have P implies to Q is logical equivalence to negation P or Q. Then we have biconditional identity, which is P is logical equivalence to Q is logical equivalence to, in bracket, P implies to Q, close bracket, and open bracket, Q implies to P, close bracket. And the last one, we have absorption loss. And for absorption loss, we have P, or in open bracket, P and Q, close bracket, is logical equivalence to P, and the other one is P and open bracket, P or Q, close bracket, logical equivalence to P.
Question 1. Simplify negation P or negation P or negation Q and P using law of logic. So for the answer is, in bracket, negation P or negation P, close bracket, or negation Q, close bracket, and P by using commutative law and associative law. Then we will use negation P or negation Q, close bracket, and P by using idempotent law. Next, open bracket P and negation P, close bracket, or in bracket P and negation Q, close bracket, by using distributive law. Next, we will have F or open bracket P and negation Q, close bracket, by using inverse law. And the last one, we will have P or P and negation Q by using identity law. So for question 2, using the law of logic, simplify the following proposition and state the reason. So we have statement, open bracket P implies Q, close bracket, and square bracket not Q, and open bracket R or not Q, close bracket, square bracket. So first, we have to copy and write the given proposition first. So we can try to look at the statement, what we can simplify or change. So I can confirm here, we can use conditional identity to change P implies Q that will equal to not P or Q. Then we will get a statement, we will get open bracket not P or Q, close bracket, and square bracket not Q, and open bracket R or not Q, close bracket, square bracket. Let's focus on not Q and open bracket R or not Q, close bracket. Here we can simplify the statement using absorption law, so it will equal to not Q. Yeah, not Q. Now this statement is open bracket not P or Q, close bracket, and not Q. Since the connective are contrary, what I mean here, not P or Q and not Q. So the connective are contrary, so we can expand it using distributive law. Then it will become open bracket not Q and not P, close bracket, or open bracket not Q and Q, close bracket. Okay, let's focus on not Q and Q. It can be simplified by using inverse law. Since the connective are N, then it will equal to F. Then we will get open bracket Q and not P, close bracket, or F. Lastly, we can simplify it using identity law, so we will get the final answer, which is not Q and not P.
Question 3. Using the law of logic, simplify the following proposition and state the reasons. The question is not round bracket P, logical equivalence to not Q, round bracket. I will explain each of this law after the explanation. First, we will be using biconditional identity, which we will get not square bracket round bracket P implies not Q, and round bracket not Q implies P round bracket square bracket. Then using conditional identity, not round bracket not P or not Q, and round bracket Q or not P. Then using De Morgan's law, not round bracket not P or not Q, or not Q or not P. Then using De Morgan's law plus double negation law, which you will get P and Q or not Q and P. Using distributive law, you will get P and Q or not Q. For inverse law, you will get P and T. And finally, identity law, the final answer you will get is P. Let me explain one by one. For biconditional identity, we need to exchange the logical equivalence into implies using their formula. Second conditional identity, we need to exchange also the implies into their formula. And for De Morgan's law, we need to implies the not for each bracket. And for double negation is if there's a not and not meet together, so it will be disappear. The not will disappear. And then distributive law, we need to expand their based on their variable, like if there's a Q and P and P. And inverse law is if it's the same variable meets and what if not, and you will get the truth value. And lastly, identity law, if a variable like P and true, you will get the variable only. So that's why the answer for this question is P, which the reason is identity law.
In conclusion, the laws of logic help us handle complex statements in a simpler and more organized way. When a statement involves many primitive statements, using these laws is more practical than constructing a large truth table. By understanding how the laws of logic work, we can apply them correctly and solve logical problems more effectively.